Well, now we're doing the review for section 2-4, and for this given equation we have to find the zeros and the degree. So let's deal with the degree first, and will you agree if we multiplied this thing out, our leading term would be x times x squared times x, which is x to the fourth times 2, so the degree is 4. It's the corresponds to the exponent on the leading term. Yeah, so degree is 4. Now, let's find the x-intercepts. Well, what value of x takes this expression to 0? 3 does. What value of x takes this to 0? Nothing will, but what value of x will take that to 0? 1 will. So the x-intercepts are at x dash I, x equals 3 or 1, and 1. There's going to be a, or 3 or 1. It can only be one or the other. Yeah, and that takes care of the x-intercepts. Let's find the y-intercepts, y dash I. Now to find those, we'll just let x be 0 and multiply what's left. So if x is 0, this is going to be negative 1 times 1, which is negative 1, times negative 3, which is negative 1 times negative 3 is positive 3, times 2 is 6. So y equals 6. And we've come up with the intercepts and the degree. Well, for question 2, we simply have to graph a polynomial of degree 1, of degree 2, 3, 4, and 5, with leading coefficients of signs positive or negative. So for degree 1, here's a graph of a degree 1 equation, like y equals mx plus b, and it's just a diagonal line, isn't it? Positive if it's going up, negative if it's going down. For degree 2, let's see. How about a parabola? There. Opening up, positive. For degree 3, now I'll draw a negative example of degree 3 there. And notice, if the degree's 1, there's no max or min. If the degree's 2, there's 1 max or min. If the degree's 3, the maximum possible maxes or mins or troughs and peaks or valleys is 2. For degree 4, an example of degree 4, there's going to be no more than 3 peaks or valleys. And for degree 5, I'll start off on a negative end. We're going to go up and down and up and, let's see, down and up. And let's count the number of peaks or valleys. 1, 2, 3, 4. So degree 5 can have at the most 4 peaks or valleys. And we're done. Okay, now we're doing question 3. And our task is to, given the average cost function on the interval 10 to 100, find the value of x that minimizes the average cost. And what is the minimum average cost? So x is the product. We've got to find the value of x that minimizes it, and then we have to find the average cost. Well, the first thing we're going to do is divide each term separately by x. And so we get 2x squared over x plus 3x over x plus 1,000 over x. Well, one of the factors of x divides out here. These divide out. And so we get c bar of x equals 2x plus 3 plus 1,000 over x. So if we cover this up, 2x plus 3 happens to be the oblique asymptote for this function. When you graph it, that's 100. And I've graphed that right here. Now, let's find c bar of 10, the lower bound, and I get 123 when I compute that. And c bar of 100, the upper bound, when I compute that, I get 213. So we'll go, this is 50. 50 and 100. So if I go up, it's about right there, that point. And that point is going to be 10 and 1, 2, 3. And the other point, when when x is 100, we're going to be over at 100 and go up to about 213. 100 and 213. And then, let's see, I did another computation, and using calculus, I came up with the low point, and it occurs at 22.4, and it equals approximately 92. So I'll go here to about 22.4, be about right there, and 92, and that's what the graph looks like. And so this happens to be 22.4 and y-coordinate of 92. And then the question is, well, look, how can we do this? You had to use calculus to do it. Here's what they're going to show on a problem or in the book. They're just going to show this curve. And they want you to recognize that the low point, wherever it is, and you can use the trace function on your calculator, or using the provided graph, you can guesstimate it with a vertical and horizontal line what the coordinates of this point are. That's all they're expecting. They don't expect you to do calculus. And so we're going to say the min occurs at x equals 22.4 approximately, and the min is approximately y equals, and I think we have 92. And now we're done. So keep in mind, you don't have to compute this. You'll just be given a graph, and you just have to recognize that the min's going to occur at the low point, and then you estimate the coordinates for that point.